Hey guys, this is what statistics is all about. Inference, I to the N to the F to the E to the R to the E to the N C E. Inference. So, the question is, what is statistical inference? So, as you notice what I put here, the idea of what's the average battery life for an iPhone? What's the average battery life for my Galaxy? Seems like a couple hours. What is the average length of time it takes to drive from here to any certain college? Okay, now all of that, we are going to be taking those different samples and making conjecture about the entire population. That is what inference is. So here, I've got two ideas of the explaining statistical inference. We're going to use the probability to determine the strength of our conclusion. And our conclusion would be, what is the chance of it really occurring? Okay, another thing is gathering conclusions about a population from samples. So, here, in the last chapter, we talked about biased, or I should say an unbiased estimator. And we said we looked at all of our samples to make a determination what was the best unbiased estimator, seeing how close it was to the true mean value, which means the population mean. Okay, but here, this idea, a point estimate, is similar to the idea. It's a value, so it's a statistic that gives us an estimate that we use for the population. So it's kind of the inverse situation. Take a bunch of samples, and a bunch of samples, and with those bunch of samples, we say, okay, we take the average of all those samples, and then we say that that must be the point estimate, and that point estimate represents the population. So as you see here, X bar, okay, the sample means, the sample proportions, but also it could be here the idea of standard deviation, again of the sample, and also the variance of the sample. So the bottom line here, statistical estimation helps us to determine how close X bar is to the unknown population. So that's different from what we did last chapter. Last chapter we said we know the population. We want to see how close those samples are to the population. But for this one, the bottom line is we don't know the population, so we want to see how close our different samples are, and from that we make a conjecture about, again, the unknown population. So let's look at our example, and as we look at our example, please pause. So the question is, how many pairs of shoes, okay, on average? And we are looking at a SRS of 20 females, and here's the data. Please notice 50 and 13 are cut off on yours, so please add it. And I'm just going to put this into the calculator and find out what my mean is. Remember, we're going to use first var stats. Okay, so here we found that it's going to be 30.35. Wow, that's a lot of shoes. Of a female teen, and yeah, I probably have just as much. Okay, now, my son had that many when he was in high school easily. Okay, now we're using this though, as I get back on point, this X bar, which is the sample right here, I'm going to use this as this is what's called the point estimator. I'm using this to estimate the entire population. Now, I'm going to go ahead and do number 2. Number 2, you don't have it. You have the 5th edition, you have the question. But the question is, using the same information right here, we want to get the estimate on the variability. They specifically wanted it to a point estimate for sigma squared, a point estimate for the variance. So, right here, since you're already on first vars, you see that you have 14.23, and of course we want the variance, so we square it to get the 202.49. Okay, please pause and read number 4. Okay, as we continue to talk about point estimates, this time we have percentages. So that 19 out of the 172 people that reported that they were willing to report cheating, okay, represents our p hat. So here, our sample proportion right here, which is p hat's going to equal to 19 over 172. And this is our estimate for the proportion. So, the bottom line here is that when it comes to inference, the first thing that we're going to be talking about is a confidence interval. In order to infer something about a population, we know if we take a bunch of samples, the sample means or sample proportions aren't going to be exactly the same. So, as we look at this Rice Krispie treat, we notice that the net weight, meaning including the packaging, is 0.78 ounces. Now, that's the weight of maybe this one. A weight of another one might be 0.77. A weight of a third one might be 0.75. The question is, what is reasonable? Because we know we can have 100 different samples and all of them will not be 0.78. So if I have 0.78 ounces going in this direction and this direction, and we have to make a determination again, what's an acceptable weight, in which at this end we're not cheating the customers and at this end we're not losing money. So a confidence interval helps us determine that. So before we talk about a confidence interval, there's a component of it, our level C when it comes to the confidence interval. So first of all, an interval is an acceptable or reasonable value for a parameter. So as I'm looking at these Rice Krispie treats, what might be reasonable is, let's say, 0.7, and then here 0.86 in terms of the ounces. That might be what's acceptable. And that makes sense because we've talked about it before. As we do manufacturing, there is no way that every Rice Krispie treat is going to weigh 0.78 ounces. But there's going to be one of them that's 0.79, another one that's 0.80, another one that's 0.75. And all of them are going to stand within that interval. But you notice here it says something about a C. And as I look at a C, there's that C percent, to be more precise, gives us how confident we are in what we do. And before we get to that, let's talk about more things about our confidence interval, though. A part of a confidence interval is what we refer to as the margin of error. Here, the margin of error is the difference between the point estimate, and remember how we talked about the point estimate on the problems up here, and the true mean value. So let's put this in perspective. The point estimate comes from what? The samples. And the true mean value, remember, that is coming from the population. That's like the manufacturer's specifications, and in this case for the Rice Krispie treats, the manufacturer's specifications, I don't know if you can see it, is 0.78. Matter of fact, here's the formula in general for the confidence interval. It's the point estimate plus or minus the margin of error. ME stands for margin of error. And as I rotate this around, here this is exactly what I just said. The point estimate is plus or minus the margin of error. Point estimate, we know, we just talked about it a couple of minutes ago, in which that is the average for that one sample. Maybe for this Rice Krispie treat, that one that I weighed was 0.75. The margin of error is the wiggle room that allows us to still be in within an acceptable interval or acceptable region. Next, here, the next question is, what is a confidence level C? Well, it gives us the overall success rate of the confidence interval. One that's a very common one is a 95% level C. Now, when it comes to interpreting these, we're just leaving these blank. We're going to talk about these in class tomorrow and how they work. But as I wrap this up here, I want you to look at the idea of, again, what truly is a confidence interval and how we interpret it. Okay, so the interpretation is saying we are 95% confident that that means if we take many samples of the same size from the same population is about 95%. Now, that to me is kind of awkward. So let me say this again. Up here, this 95% that would be here is going to go in here. So saying that we are 95% confident, we're not saying that we're 95% sure. We're saying 95% confident means that if we take many samples, and they have to be the same size, from the same population, about 95% of them will be captured within an interval in relationship to the true mean value. What that means is this. Let's look at the Rice Krispie treats. And the true mean value, we know here is 0.78. Now let's stick with the numbers I have here. I'm going to give myself a confidence interval that is between 0.7 ounces and that 0.8 ounces. Okay, so I weigh one of the Rice Krispie treats. The weight is 0.75. I weigh another one. I have it being 0.81. I weigh another one, 0.8. I weigh another one. It's actually 0.78, the factory specifications. And I just get a bunch of weights, and as I get these weights, okay, they're inside of this interval. But let's say that I get one bag, and there's always the black sheep, one of them, that is actually 0.65. Well, that's outside of the interval. But what we're saying with the 95% confidence, we're saying that we are 95% confident that all of these are going to be within an interval given the true mean value of 0.78. So that means in here, if I were to get 100 bags, that 95 of them would be inside of this interval, while 5 of them, because remember I said if it was 100 of them, would be outside the interval. We're going to do a project, depends if I can make it to Costco, whether it's going to be tomorrow or on Friday, so that we can get a better handle on the idea of a confidence interval. Okay, so when you come in class tomorrow, be ready to have an in-depth discussion. Have a good evening. Bye-bye.